Okay, for this question, we're gonna find the exact length of the polar curve for r equals 3 plus 3 sine theta. First of all, we're gonna find the derivative of this one. It's 3 cosine theta, and we're gonna write it in this form. And then we're gonna draw the polar plot of the original equation. We're gonna find the value for r and theta, and then we're gonna draw the plot. And it's like this. From the plot, we can see that the both sides of the between the y-axis are the same. So we know that take the length from pi over 2 and 3 pi over 2 multiplied by 2 would be the entire length. So from this, we can get the equation. The length equals 2 times the length from pi over 2 to 3 pi over 2. And we're gonna solve this equation. We're gonna open up the bracket and we're gonna add them together. And finally, we can get this equation, which is pretty hard to solve. 2 square root of 18 empty bracket square root 1 plus sine theta. To solve this, we're gonna multiply it by 1, and we're gonna substitute 1 with square root of 1 minus sine divided by square root 1 minus sine. And then we're gonna get this. We multiply them together and we get this one. The top of the equation would be 1 minus sine square will be cosine square. So the square root of cosine square will be cosine. Yes, just cosine. And then we're gonna solve this by using the integral. We're gonna use u equals 1 minus sine theta, and du gonna equal to negative cosine theta. And then we put this back into the original equation, and then we're gonna solve the antiderivative of this, and then we get 2 square root of 18 times negative 2 square root of u. And then we're gonna substitute this equation back into u, and then we got this. And finally, we're gonna solve for the final range of this. After solving this range, we got an answer. That is negative 24 plus 12 times the square root of 2. That will be the answer of this final question.